Hello everyone, today we're taking a look at topic 6 of our mastery check reviews, and we're going to be talking about the double angle formulas today. So starting off with the level 1 question, it just says, what are the double angle formulas? And we're going to write them down here so that we have them in front of us because they're going to be super useful to solving these problems. So we know that sine of 2 theta is the one that's equal to 2 times sine of theta times cosine of theta. So you multiply sine and cosine, put the 2 in front. Cosine's a little bit tricky because you got to remember 3 separate formulas. The first one being very similar to our Pythagorean identity, but it's a little bit different. So it's cosine squared theta minus sine squared theta. And each other one is just a little modification of that, where if I were to replace cosine squared or sine squared with its Pythagorean identity, 1 minus the opposite one, 1 minus sine squared or 1 minus cosine squared, we end up with the answers for the other one. So the first way is that when we change it and keep just the sine squares, we end up with 1 minus 2 sine squared of theta. Whereas we flip it the other way and we remove the sine squared, we end up with 2 cosine squared theta minus 1. And the last one is the tangent 2 theta. That one's a little bit longer, but it's going to end up coming out to the fraction of 2 tangent theta on top over 1 minus tangent squared theta on the bottom of that fraction. So having the 5 of those is definitely going to help you and make sure that you are confident in doing successfully on this test. So the first question says, find the cosine of 2 theta for the following. Cosine of theta equals negative 5/13 and theta terminates in quadrant 3. So we're going to start by drawing this coordinate plane. And it tells me it terminates in quadrant 3. So I know that I'm going to put my triangle down here in quadrant 3. And that is going to be the replica of our triangle where theta is close to the origin. Now, again, using these formulas that we talked about in the last mastery check, it's that cosine is adjacent over hypotenuse. So the adjacent to theta is going to be right here, and the hypotenuse is going to be here. So that's where my top number will go on adjacent, the 5, and then the hypotenuse is 13. The other thing we got to address is the fact that we are moving left and then down. If we move to the left, that represents a negative, and if I move down, that also represents a negative. So this 5 is going to be negative, and this missing number is going to end up being a negative. And so we need to figure out what that missing number is, and we're going to use Pythagorean Theorem to do that. So negative 5 squared plus b squared equals 13 squared. I end up with 25 plus b squared equals 169. And when I subtract the 25, I get b squared equals 144. So b equals 4. And again, since it's going down, we know it's going to be a negative. And the 3 pieces of information we really need to pull from here is what the sine of theta is, the cosine of theta, and the tangent of theta. So sine of theta is equal to the opposite over the hypotenuse. So in this case, the opposite side of theta is that negative 4. So we're going to end up putting negative 4. That's in the wrong spot. We end up putting negative 4 over the hypotenuse, which is 13 here. Cosine of theta, they already gave us. They told us cosine of theta is negative 5 over 13 in the direction. So let's just keep that. And last is tangent of theta, that the y divided by the x, or the opposite over the hypotenuse. In this case, the opposite and the hypotenuse are both negative. Negative 4 and negative 5. So negative 4 over negative 5 cancels out and just gives us 4 over 5. But that brings us to the situation that we can now answer our question. So we know that the cosine of 2 theta formula is equal to cosine squared minus sine squared. So all we need to do is plug in our cosine and square it and subtract our sine and square it. So that's what we're going to go ahead and set up here. Our cosine squared is negative 5 over 13 squared minus, and our sine squared is negative 4 over 13 squared. So I'm going to square the top numbers and the bottom numbers separately. So in this first one, negative 5 squared is 25 positive, and 13 squared is 169. Over here I got minus, and I got negative 4 squared, which gives me positive 16, over 13 squared, which is 169. So I'm going to keep the 169 on the bottom, and 25 minus 16 is 9. And that is going to be as far as that can go. All right, for the level For the level 3, same idea, but it says find the sine of 2 theta for this problem. So we need to figure out the cosine here as well, because sine of 2 theta is equal to 2 sine of theta cosine of theta, and I only know the sine of theta. So I need to draw a picture and figure out what the cosine of theta is as well. So what I'm going to do is I'm going to draw my picture here. I know that sine is terminating with a negative, so it's got to be in either quadrant 3 or quadrant 4. And it literally tells me it terminates in quadrant 4. So I'm going to draw my picture so that it's in the 4th quadrant. And since sine is opposite over hypotenuse, I know my opposite is going to be 3. My hypotenuse is going to be 4. And we know that the opposite is going to be the negative because the hypotenuse can never have the negative. And we do our Pythagorean theorem here. Negative 3 squared plus b squared equals 16 squared. That's not 16 squared, that's 4 squared, I'm sorry, which is 16. I'm like, that didn't come out right. We'll subtract our 9 here, and we get b squared equals 7. And when I square root both sides, I get b equals the square root of 7. So this is the square root of 7, and we obviously know that this is not a situation where we have to, There we go. All right, so now we can go ahead and move into solving the next parts of these problems, which, again, we already knew that the sine of theta was equal to negative 3/4. What we need to know is what the cosine of theta, which is the adjacent over the hypotenuse, is. So my hypotenuse is still 4, but my cosine is going to be square root of 7 over 4. And again, what I was saying earlier, we don't need to put a negative on the square root of 7 because it's moving to the right, so we don't need to worry about that. So setting this up, we got 2 times sine times cosine. So 2 stays. Sine of theta is going to be negative 3 over 4. The cosine of theta is going to be square root of 7 over 4. And we're just going to multiply that straight across. So 2 times negative 3 is negative 6. Negative 6 times square root of 7 is negative 6 square roots of 7. And on the bottom, technically there's a 1 here. So 1 times 4 is 4. 4 times 4 is 16. And all I need to check now is do these two numbers simplify, negative 6 and 16, the two outside of the square root. And they would both divide by 2. So I end up with negative 3 square roots of 7 over 8. And the last one here says, suppose sine of theta is negative 4/5 and tangent is less than 0. Find the tangent of 2 theta. So in this case, again, drawing our picture, we know that sine is negative, so it's got to be in the bottom half. And since tangent is less than 0 this time, it's negative, so it can't be in quadrant 3, which means our triangle has to be in quadrant 4 this time. And working in our pieces, we know that theta goes here. The opposite of theta is negative 4, and the hypotenuse is the bottom number 5. And you'll notice that if you did Pythagorean Theorem in the last one, you know the answer here already. We know that it's going to be 3 as well on top. 3 to the right and then 4 down, so it's going to be a positive 3 and a negative 4. And now I can go ahead and set up this problem, tangent of 2 theta. Since we know that tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared, all I really care about is figuring out what the tangent of theta is. So tangent of theta is opposite over adjacent, so the opposite is negative 4 and the adjacent is 3. So we're going to plug negative 4 over 3 into this problem. So 2 times negative 4 over 3. And 1 minus negative 4 over 3 squared. So we just talked about squaring those fractions. We're going to square the top and square the bottom separately. And on top, we'll just multiply. So 2 times negative 4 is negative 8/3 on top. And on the bottom, we got that 1. We'll come back to it. We've got minus, and then the negative times the negative on the inside is going to cancel. 4 squared is 16. 3 squared is 9. So I really want to write this number 1 as 9 over 9. So I took this 1 and made it 9 over 9 to space out my work a little bit better so I don't have to go back and rewrite it again. So I end up with negative 8 over 3 divided by negative 7 over 9. And we'll do our keep change flip now. So negative 8 over 3 multiplied by the reciprocal, negative 9 over 7. Little cross simplification here. 3 can divide into 3 and 9, so this is going to become 1 and 3. And negative 8 times 3 is negative 24, and 7 times 1 is 7. All right, hopefully that helped a little bit. If you need any more help, please come see me so I can get you in the right path. As always, have a fantastic day, everybody. Bye.